Hi everybody, Mrs. Pesic here. We are looking at section 12.5, angle relationships in circles. Your goals are to find the measures of angles formed by lines that intersect circles and use angle measures to solve problems. Let's take a look at this first theorem. In this theorem it says if a tangent and a secant or a chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So at any time during this video, feel free to stop and pause or rewind as you need. So the hypothesis for this theorem says that if you have tangent BC and secant ray BA, they intersect at point B. If that's the case, then the measure of angle ABC is going to be half of the measure of the intercepted arc, which would be AB. So in this case, for example, if we knew that arc AB was 80, then we would know the arc is 80, then we would know that the measure of angle ABC would be half of that arc. So we would know that it would be half of 80. So we would know that this angle would be 40 degrees. All right? So let's take a look at this example. We're trying to find the measure of angle BCD. If we have arc BC, they're showing us here that arc BC measures 142. That arc is formed by this secant, ray CB, and this tangent ray CD. So that means that this angle, measure of angle BCD, is going to be half the measure of arc BC. So if we know that the measure of arc BC is 142, then the measure of angle BCD is going to be half of that. So the measure of angle BCD is going to be 71 degrees. All right, and so, hello. And so now if we're trying to find the measure of arc ABC, let's go the other direction. Let's get this down. Slide this off to the side a little bit. So if we want to find the measure of arc ABC, that's going to be measure of arc ABC. Half of that arc is going to be equal to the measure of what angle? Well, let me erase what I have here, because now we're talking about this arc, ABC. That's this entire arc. And so what angle kind of would be forming that? Well, still this tangent ray CD, and now this time ray CA, if you want to think of that as a secant, and that we see is a right angle. So again, the measure of angle ACD is going to be half the measure of arc ABC. Well, we know that the angle is 90, so I get that 90 degrees is going to be half of the measure of arc ABC, and so I can just multiply both sides of the equation by 2, and I get that it's going to be 180 degrees. Those 2's are dividing out. So the measure of arc ABC is 180, which makes sense. Are we okay with this? I hope so. Let's take a look at the next theorem. I didn't write my answer in here, so this should be 180 degrees. Okay, let's take a look at this theorem. It says if two secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. So for example, if we have chords AD and chord BC intersecting at point E, if that's our setup, then we can find the measure of angle 1 by taking the half of the sum of these two intercepted arcs. So, for example, if we had, let's just come up with a quick example here. Let's say I've got this chord and this chord crossing somewhere in the circle, and I know that this arc is 50 and this arc is 70. If I'm trying to find this angle here, then the measure of, I'll call this angle 1. The measure of angle 1 is going to be half of the sum of the 50 plus 70. So that would be half of 120, and that's going to be 60 degrees. So the measure of angle 1 would be 60 degrees. Let's take a look at this example. In this example, we're trying to find the measure of angle SQR. Angle SQR is this angle right here. I see that that angle is formed by two secants that are intersecting in the interior of the circle. So the measure of angle SQR is going to be half of the sum of the two intersected arcs. That means half of the sum of the measure of arc PT plus the measure of arc SR. Well, we see that the measure of arc PT is 32 degrees, and the measure of arc SR is 100 degrees. So we get half of 132, and half of 132, when we divide that, or multiply, we get 66. So the measure of angle SQR is going to be 66 degrees. All right, let's take a look at this theorem. This one says if a tangent and a secant, two tangents or two secants intersect in the exterior, I'm going to highlight that. Because we're talking about intersecting in the exterior of the circle, then the measures of the angle formed is half the difference of the measures of the intersected arcs. So if it's an exterior, then you're going to have half the difference, whereas back here with this theorem, it was if it measures in the interior, then it's going to be half the sum, right? So this point here was in the interior, that intersection point, whereas in these examples, that intersection point is in the exterior for all of them. All right? So the formula says to find the measure of the angle formed, it's going to be half the difference of the measures of the intersected arcs. So if it happens to be a tangent line and a secant line, then we're going to have this arc and this arc. We're going to have to take, this one minus this one, and then take half of that to get the angle. If it happens to be two tangents, you're going to take this arc here and subtract off this arc here, and then take half. All right? And if it was this angle here that's formed by two secants, we're going to have to take this arc minus this arc and then multiply by 1/2 to get the angle measure. So let's take a look at some examples. For this first one, if we're trying to find the value of x, the measure of angle x, or x is going to be 1/2 the difference between, I'll say, the measure of arc RS, that's this arc here, and minus the measure of arc QS. All right, and so in this case, it's going to be half of 174 minus 98. So on graphic calculator, we're doing 174 minus 98. I get 76, and then I want 1/2 of that, so I'm ending up getting 38 degrees for x. That's going to be 38 degrees. Let's take a look at this next example. Again, we see for both of these, the intersection for the the tangent and the secant here was in the exterior. Here it's two tangents, but again, that intersection point's in the exterior. So we want to use our formula that says the measure of angle, or I'll just say x in this case. X is going to be found by taking 1/2 of the difference between, in this case, it's going to be the measure of arc EHG. That's this arc from here around to here, minus the measure of arc EG. That's just this little arc here. All right? So what are we going to write? We're going to say 1/2 of, well, they didn't give us a measure for EGH. So EHG. So how are we going to find that measure? Well, I noticed that this arc here and this arc here, they form the whole circle. So together, they form 360 degrees. So I can do 360 minus 132 to get that angle. And on my calculator, I'm getting 228 degrees. So that's this angle here, 228 degrees. So I want 228 minus 132. Remember, that's this arc here was 132 for that measure. So I want 228 minus 132. I'm getting 96. So I get 1/2 of 96, and 1/2 of 96 is 48 degrees. So x turns out to equal 48 degrees for this one. All right, let's take a look at this example. When a person is farsighted, light rays enter the eye and are focused behind the retina. In the eye shown, light rays converge at point R. If the measure of arc PS is 60 degrees and the measure of arc QT is 14 degrees, then what is the measure of angle PRS? So in this case, notice the eyeball here sure looks like a circle, right? It's like a circle right here. There's our circle, right? And so we have our PS, if you will. Our PS here is like an arc on a circle, and they tell us that that arc measures 60. So I'm just going to kind of bring our circle down here and maybe draw our sketch a little bit. So I've got a segment, a secant like this and a secant like this. And so what do I know about this picture? I know that this is P, this is S, and they told us that this is 60 degrees. And I know that this is Q, and this is T, and this is R. And they told us that QT is 15. The measure of arc QT is 15 degrees. So to find the measure of angle PRS, that's this angle right here, the measure of angle PRS is equal to 1/2 of the difference between these two arcs. So 1/2 the measure of arc PS minus the measure of arc QT, because those two arcs are the intercepted arcs that are formed by the two secants. So in this case, I want 1/2 of PS is 60, QT is 15, so I need 1/2 of 60 minus 15 is 45, so half of that would be 22.5. So the measure of angle PRS is going to be 22.5 degrees. All right, we got one last example. And it says 2 of the 6 muscles that control eye movement are attached to the eyeball and intersect behind the eye. One of those muscles is called the superior oblique, and the other is called the inferior oblique. So if the measure of arc AEB is 225, slide this picture down a little bit. So if I have the measure of arc AEB, that's this arc right here, measures 225 degrees. What is the measure of angle ACB? That's this angle right here. Well, in order to find that angle, we're going to need to find the measure of this arc, and they did not give it to us. So how are we going to find that? Well, remember, this arc plus this arc form the entire circle. So we just need to do 360 minus 225 to get the measure of that arc, and it turns out to be 135. So this arc measures 135. We're now in business, and we can find the measure of the angle. So let's set this up. We want the measure of angle C, and it's going to be half of the difference between the measure of arc AEB minus the measure of arc AB. All right, and so in this case, we want half of 225, that's this arc, minus the measure of arc AB, that's this arc here, so that's 135. And so when I subtract, I get 225 minus 135 leaves me with 90, and then I want half of 90, so the measure of angle C is going to turn out to be 45 degrees. Okay, that ends our video. I hope you took good notes on your guided note sheet, and thanks for watching.